Today's lesson deals with the properties of triangles, similar triangles, and triangles that are the same size. Now, we're going to be working on this problem here to start. Now, here's the first thing that you need to understand. Any line that cuts across another's line is called a transverse. So that means this thing here is a transverse line because it cuts across that line. Now, if I look at those two lines, they cross. Now, because they cross, there are 2 points there are 2 angles that are the same, and they are on the opposite sides of the center. And the same can be said about the 2 horizontal sides there, x and x. We call anytime we use this property, we say that we're using opposite angles to justify that. Now, if I have an angle, let's say that the small angle of this one here, when we're looking at it, is x. You know that one line that goes from here to here is 180 degrees, right? Now, we know that it's 180 degrees, so if x is the smaller angle, then we have 180 minus x being the opposite angle. Now, we call that rule, that possibility, we call that supplementary rule, or due to supplementary angles. Now, our next problem deals with this. Now, you'll notice that we have a small box there. That small box tells us that this is a right triangle. Sorry, right angle. Now, a right angle is also known as 90 degrees. Now that we've got that, suppose that this angle that comes out of that arm is x. That means this is 90 minus x. And we're going to call that complementary angles. You'll see something like that from time to time when we have triangles inscribed in squares, things like that. Now, when we have 2 parallel lines and this line here cuts across it, remember what I said? It's called the transversal, or the transverse line. Okay? Now, what I'm looking for are similar angles that cut across these 2 parallel lines. And we'll use that to find those appropriate angles. The first thing that you're going to see is that from here to here, we have a Z pattern here. Now, you used to call that a Z pattern, and what Z patterns did was it allowed us to find angles that were the same. The angles happen at the kinks in our Z angle, Z triangle. Now, I could have another Z pattern here. Okay? I could have another Z pattern, and my other Z pattern could look like this. So I could go and take my highlighter, and this time I'm going to use blue. If I come across and go down, and then go across again, we have 2 more related angles. We have an angle here, let's call it Y, and another matching angle Y here. You'll notice that when we have Z patterns with a transversal, there's always only 2 Z patterns per line. 2 Z per transverse. Now, you could also have used your supplementary angle rule to find the opposite angle across those 2 transverses, which are these 2 parallel lines here. You could have found this angle here and then taken 180 minus this angle to find its y value. Okay, now our next problem deals with a thing called the F pattern. The F pattern looks something like this. Let's use pink this time. So it looks like an F. Now, the only places that are similar, that work together, that are the same, are things like our angles that happen here and here in our F pattern. They happen in the kinks that make contact with the stem of the F pattern. Now, I could have another F pattern in here. I could have a backwards F. Okay, you'll see that, and you'll notice that we have, I could have basically written, say, let's call that Y, and this one would also be Y based on the Z pattern. Sorry, the F pattern. Now, I have another one that shows up as well. If I go and use another one, we're going to have another one that looks like this. Well, an upside down F this time, but flipped. And then I could have another F. So the F pattern is the most useful one. So the F pattern is the most useful, and in this case, my matching letters would be Y and Y here. Now, with the F pattern, okay, this is what you need to know. There's always, the F pattern can be flipped and reversed to find more possibilities, and altogether there are usually 4 possibilities because of how the F pattern can be flipped. Now, the last one that we're going to do for today is the C pattern. The C pattern basically looks like this. It looks just like a C. Now, the angles that we have here are X and 180 minus X. Some mathematicians would call this the C pattern, also known as the complementary angle configuration. Now, the C pattern is very similar to the Z pattern, as we have only 2 patterns per transverse, per line that cuts across. So remember, this is called the transverse line. So now we'll do just a quick recap of what we just studied. Well, when we studied this stuff, right, we use opposite angles to identify opposite angle sides. When we use supplementary angles total to 180 degrees. That's why we have X and 180 minus X. Now, for complementary angles, the total of both angles should be 90 degrees. And then from here, we started looking at our Z patterns. Our Z patterns come in only 2 possibilities, a normal facing Z and a backwards facing Z. And basically, the kinks that we have in our angles, in our Z patterns, allow us to find matching angles. Now we also have the F pattern. The F pattern is awesome in the sense that the F pattern allows us to find 4 different possibilities. So for example, I got my first F. Then I have another F that's flipped to the left. And then I could have another one that's flipped upwards to the left, and another one that's flipped upwards on the regular F. So we have 4 different possibilities to find our missing angles. Now, this last one here. This last one basically uses the C pattern to find its complementary angle within the other parallel line. And we call that the C pattern shape.